Good morning from Cape Canaveral Space Force Station in Florida. I'm Stephen Clark, editor of spaceflightnow.com, and welcome to another live stream, live coverage this morning of the rollout of the United Launch Alliance Atlas V rocket. The Atlas V is currently located in the building with the U.S. flag in the middle of your screen. That's the vertical integration facility, a 30-story tall building where ULA stacks components for its Atlas V missions. The Atlas V is scheduled to emerge in a few minutes. The original rollout time was set to begin at 10 a.m. Weather conditions are a go for rollout this morning. Once the rollout begins, the entire journey to Pad 41 will take about an hour. Space Launch Complex 41 is located about 1,800 feet. That's about 550 meters north of the building you're looking at now, the vertical integration facility. This mission will mark the 94th flight of an Atlas V rocket and the 4th Atlas V mission of the year. This mission is designated USSF 12, United States Space Force 12. It'll be carrying 2 Space Force satellites into a high altitude geosynchronous orbit, more than 22,000 miles or nearly 36,000 kilometers over the equator. This mission will require a heavy lift from the Atlas V. The Atlas V in this mission will be augmented with 4 strap-on solid rocket boosters, and the Centaur upper stage on top of the Atlas V will be performing a series of burns to place the USSF 12 payloads into their targeted orbit. The entire mission from liftoff till final spacecraft separation will last more than 6 hours. Liftoff of this mission is scheduled for 6 p.m. Eastern Time or 2200 UTC tomorrow, Thursday, June 30th. The mission has a 2-hour window available to get off the ground tomorrow. And today's activity, as I mentioned, is the rollout or transfer of the Atlas V launch vehicle to Pad 41 to prepare for tomorrow's countdown. In this view from the east, looking toward the west, you can see the vertical integration facility in the middle of your screen. In the background is the even larger, in the distance, the even larger vehicle assembly building at NASA's Kennedy Space Center is visible on the horizon. We're about 4 miles from the VAB and less than a mile from the vertical integration facility at our current location at Cape Canaveral Space Force Station. In this view from our other camera position over at the Kennedy Space Center press site, which is actually near the VAB, you're looking east toward Pad 41 from the opposite direction. On this, in this viewpoint, on the right side of your screen is the integration facility, and the rocket will be rolling from right to left in this view toward Pad 41. The general direction of the rollout is to the north from the VIF to the actual launch complex. In the previous view from the east side of the pad, we expect to see the rocket roll from left to right. While we're waiting for the Atlas V rocket to make its emergence from the vertical integration facility, a few miles to the north, Spacex is continuing construction of the new launch tower for the next generation super heavy booster and Starship vehicle. This is a giant rocket that will stand nearly 400 feet tall. It'll be the tallest and most powerful rocket ever to fly. And this new launch pad is being built inside the perimeter of Launch Complex 39A at the Kennedy Space Center. Again, that's just a couple of miles north of the Atlas V's launch site at Space Launch Complex 41. This morning, the 3rd segment of this Starship tower was lifted onto the lower 2 segments. So now 3 potentially as many as 9 segments of this giant tower are now stacked in place at pad 39A. We expect to see more of those segments make their way from a fabrication site nearby at the Kennedy Space Center out to 39A in the coming days and weeks to complete the buildup of this launch tower gantry. And then once the structure is built up, SpaceX construction teams will complete the outfitting of that structure with various propellant lines and support systems and ground systems before the site is made ready for the first Starship launch from Florida. A similar launch site is already built in Texas. Back to Complex 41, the rollout officially has begun according to United Launch Alliance, but from our vantage point, we won't be able to see the rocket until it clears a certain distance away from the BIF, the vertical integration facility. So this rollout is now officially underway, and we expect to see the rocket emerge in a few moments. And now we're seeing the first signs of the Atlas V emerging from the vertical integration facility, just beginning to peek out the door, the giant vertical door on the north side of the BIF. And now we have a really nice view of the Atlas V. Now emerging from the vertical integration facility, the Atlas V stands, in this configuration, stands 196 feet or about 60 meters in height. And as I mentioned, it's augmented for this particular mission by 4 strap-on solid rocket boosters produced by Northrop Grumman. These boosters are called graphite epoxy motors, or GEM 63. So 63 designates their 63-inch diameter of these motors. And together, the 4 strap-on boosters and the RD-180 core stage engine produce about 2.3 million pounds of thrust to power this nearly 20-story tall vehicle off the pad tomorrow. The Atlas V continues to be at a hold point right outside the vertical integration facility. This is a typical point where the ground team at Pad 41 pauses the rollout after clearing the VIF to make sure that everything's in proper alignment. All conditions are good to go for the continuing of the rollout to Pad 41. This entire journey is about 1/3 of a mile in length from the vertical integration facility to the launch mount at Complex 41. As I mentioned, this is the 94th Atlas V rocket to fly since the debut back in August of 2002. It's one of 23 Atlas Vs still remaining to fly. ULA says it has sold all of those Atlas Vs to customers. The lion's share of the remaining Atlas V missions will be for Boeing's Starliner crew capsule program, carrying crews up to the International Space Station, as well as for Amazon's Kuiper broadband network. There are 7 Atlas Vs currently assigned to the Starliner program, all carrying astronauts to the International Space Station, 1 test flight, and 6 operational missions, and 9 Atlas Vs have been sold to Amazon to build out that company's planned broadband network called Kuiper, which is a competitor to SpaceX's Starlink network, as well as OneWeb's internet network. One of the things to note for this mission is it's the 100th flight of an RD-180 engine. The RD-180 is produced by MPO Energomash in Russia, and all Atlas Vs have been powered by RD-180 engines, one engine on each mission at the bottom of the core first stage booster. So this will be the 100th RD-180 engine to fly. Again, the 94th Atlas V, there were 6 RD-180 engines that flew on the predecessor Atlas III program, which tested out systems and was a transition program from the legacy Atlas rocket fleet or Atlas rocket program and the new generation Atlas V, which debuted in 2002. After the retirement of the Atlas V, ULA will transition all of its launches to the next generation Vulcan program, which will be powered by US-made engines, the BE-4 engine produced by Blue Origin. Some other stats for this mission, launching tomorrow. This will be the 676th launch of a rocket bearing the Atlas name since 1957. These launches include test launches of the Atlas missile in the Cold War era, as well as all the different iterations and versions of the Atlas rocket program dating back 65 years ago to 1957 until today. Will also be the 265th flight of a Centaur upper stage. The Centaur is a cryogenic stage fueled by liquid hydrogen and liquid oxygen. And the Centaur stage debuted back in the 1960s, in the mid-1960s, and has flown on various Titan and Atlas rockets. In this view, you can see the payload fairing for the Atlas V. This is the 5.4 meter diameter or nearly 18-foot wide version of the payload fairing for the Atlas V. The Atlas V comes in several different payload variants with two different diameters, a 4 or 5 meter diameter version of the fairing, depending on the type of payload it's carrying. And there are also short, medium, and long versions of the 4 and 5 meter fairings. This is the 5 meter small version. The fairing is built by a company called Beyond Gravity. You may know that name formerly as RUAG Space, the Swiss company that builds payload fairings for the Atlas V rocket. It'll be continuing to build the fairing for ULA's next generation Falcon Centaur rocket. And RUAG also, or now Beyond Gravity, they've renamed themselves, also builds the payload fairing for the European Ariane 5 and Vega rockets. And all these fairings are a little different in size and purpose and design, but they all have the same basic structure and composition, and they're tailored for each type of rocket. The payload fairing for the Atlas V is now actually built by Beyond Gravity or RUAG at ULA's factory in Decatur, Alabama. This factory, this fairing fabrication facility in Decatur came online recently. Previous Atlas V fairings were all produced in Switzerland and delivered to the United States for launch on the Atlas rocket. And the rollout has resumed. The Atlas V and its mobile launch platform are once again in motion, heading north toward Pad 41 in preparation for launch tomorrow with the USSF-12 mission. USSF-12 stands for United States Space Force 12, and that's the code name for this mission, as many Space Force missions are now known by number designators. The payloads on this mission are the Wide Field of View test bed. This is testing a next generation infrared sensor for missile warning and missile tracking. And the other payload on this mission is called the USSF-12 Ring. And that's actually a propulsive ring-shaped spacecraft that will be hosting a number of classified experiments and payloads in geosynchronous orbit. This rollout of the Atlas V launcher is now about halfway complete. It's about midway between its starting point at the vertical integration facility and its destination this morning at Space Launch Complex 41. It's a beautiful morning here on the Space Coast of Florida. The weather for tomorrow's launch is a little more iffy, however, with a 60% chance, favorable conditions, a 40% chance of weather potentially violating one of the launch commit criteria for tomorrow's 2-hour window, which opens at 6 p.m. Eastern Time or 2200 UTC. Meanwhile, while this Atlas V rollout is underway this morning, SpaceX has been in action at 2 different launch pads today. Crews out at pad 39A have stacked the 3rd segment of the Starship orbital launch tower on top of the first 2 segments. This segment rolled out to pad 39A earlier this week, actually Monday night, if I recall correctly, from a fabrication site elsewhere at the Kennedy Space Center, continuing to build up that location, that complex for future Starship and Super Heavy missions. Meanwhile, to the south of pad 41, next door at pad 40, a SpaceX Falcon 9 rocket is vertical this morning for a launch this afternoon at 5:04 p.m. Eastern Time. That is 2104 UTC, with the SES-22 commercial communication satellite. This is a satellite that'll be going to geostationary orbit to provide C-band TV broadcast services over the United States. In this zoomed-in view, you can see the four strap-on solid rocket boosters pretty easily visible on each side of the bronze-colored core of the Atlas V vehicle. Two of the boosters are on the south side of the vehicle. On the right, you can just make out behind the core stage one of the two on the north side of the first stage. These will produce about 1.5 million pounds of thrust together. And along with the more than 800,000 pounds of thrust of the core stage RD-180 engine, the entire vehicle will climb off the pad tomorrow with 2.3 million pounds of thrust. These boosters are produced by Northrop Grumman. They're called the graphite epoxy motors, or GEM 63s. 63 designator represents the 63-inch diameter of each of these boosters. In this view, you can see that the Atlas V is nearing its destination. It's not quite on the pad just yet. On the right side of the screen is the ULA crew access tower. This is the structure that was built a few years ago to accommodate crew launches from this launch site. This will be used in the future for missions carrying astronauts on Boeing's Starliner crew capsule. They will ride the elevator up this crew access tower and then walk across the crew access arm into the white room, which is the white box feature near the top of this crew access tower. And that white room is the room that connects up to the hatch on the Boeing Starliner spacecraft for astronaut boarding during an Atlas V countdown. No crew missions have flown yet on the Starliner, but the most recent Starliner test flight back in May achieved its objectives and has cleared the way for preparations to begin in earnest for a crew launch, a crew test flight on the Starliner either later this year or early next year. There's no official target schedule yet, but Boeing has said they aim to have the spacecraft ready for a launch by the end of the year. And that mission will carry a crew of 2 astronauts to the International Space Station. And then future missions will start operational crew rotation service on the Starliner, carrying up to 4 astronauts at a time for 6-month stints on the ISS. And with the on-ramping of the Starliner, NASA will have 2 vehicles on contract along with SpaceX's Crew Dragon. They're capable of carrying astronauts to the space station. It does appear that the Atlas V is now inside the fence at pad 41, but it is stopped again. This is a normal part of the rollouts. It often pauses just outside the vertical integration facility, which we did see earlier this morning. And then as it approaches the final position over the flame trench at pad 41, the rollout usually slows down to ensure proper alignment of all the structural, mechanical, and fluid connections that will be made between the mobile launch platform and the ground systems at the pad. The Atlas V rocket is now passing behind one of the four lightning protection towers at Pad 41 in this. These four towers are in place to protect the rocket from lightning strikes while it's on the pad. Most of the launch facilities, in fact, all the launch facilities here on the Space Coast at Kennedy Space Center or at Cape Canaveral Space Force Station have some form of lightning protection. And Pad 41 has four of these towers. These were originally built up for the Titan rocket. They've been in place for decades now and have been repurposed and reused for the Atlas V rocket. A similar set of lightning towers you may be familiar with seeing are located around Pad 40, used for SpaceX Falcon 9 launches, including a Falcon 9 launch scheduled to go up this evening, this afternoon, really at 5:04 p.m. Eastern Time or 21:04 UTC. Both of these pads, Pad 40 and 41, are very similar in layout. They were built, as I mentioned, in the 1960s for the Air Force's Titan rocket program and hosted a number of Titan launches, culminating in the Titan 4 program, which last flew from Pad 40 in 2005. And then that pad was handed over to SpaceX by the Air Force for Falcon 9 launches. And much of the Titan infrastructure of both pads are gone, with SpaceX and ULA not requiring a lot of the infrastructure that was built for the Titan rocket. However, they have reused some elements, including the lightning towers and some of the earthworks, the flame trench at the pads have been reused with modifications for the Falcon and Atlas launches. And it looks like the Atlas V rocket is now in the final stretch to ensure proper alignment with the various systems that the mobile launch platform needs to connect up to at the pad. These include not only mechanical alignments, but also lining up the fluid lines, which will be joined together between the ground side and the mobile launch platform via a series of autocouplers. These autocouplers will feed propellants and other fluids into the Falcon, or the Atlas V rocket rather, during the next day, beginning this afternoon, with the loading of kerosene fuel into the first stage. This kerosene is called RP1. It's rocket grade, highly refined kerosene that will be consumed by the RD-180 engine. And then during the countdown tomorrow afternoon, ULA's launch team will load cryogenic propellants into the vehicle. These are super cold fluids. Liquid oxygen will be loaded into both the first stage and the Centaur upper stage. And then liquid hydrogen will be loaded into the Centaur upper stage to power that part of the rocket, which is powered by an RL-10 engine produced by Aerojet Rocketdyne. And that RL-10 engine will fire multiple times during tomorrow's mission to do the fine maneuvers to place the two payloads on this rocket for the United States Space Force into a near geosynchronous orbit, and finally deploy those satellites in their targeted orbit more than 20,000 miles over the equator, about 6 hours into the mission. This zoomed in shot, you can really see the logos on the payload fairing, the American flag, the Atlas logo, as well as the United States Space Force insignia and the mission logo for the USSF 12 mission, which is what this rocket will be carrying into orbit tomorrow. And just behind the rocket is the crew access tower I mentioned earlier, built up for the crew launches on the Boeing Starliner spacecraft and the Atlas V rocket. For those future missions with astronauts, the crew would actually go up that tower on an elevator and then walk across the access arm to the light room, which is retracted in its current configuration just to the right of the Atlas V's payload fairing. That's where the light room is located, and that's the entry port that would hook up or connect up against the hatch, the side hatch of the Starliner spacecraft, to enable astronauts to actually board the capsule during the countdown. And it looks like the Atlas V rocket has now arrived at Space Launch Complex 41. If it's not directly in position, it's looks like it's mere feet or inches away from its final position to align the mobile launch platform over the flame trench and to enable the ground crew at the launch complex to make all their connections between the mobile launch platform and the pad facilities themselves. This completes the 1,800-foot journey of the Atlas V from the vertical integration facility. And in this wide view of the pad, you can see those 4 lightning towers on each side of the Atlas V. And I'll call your attention just to the right of the pad in the distance is pad 39A and pad 39B at the Kennedy Space Center. The Space Launch System, NASA's Artemis 1 moon rocket, is just above the liquid oxygen tank at pad 41, that white sphere. Just above that white sphere is the top of the Space Launch System in the distance. And then to the right of that, you can see the crane in place for construction of SpaceX's Starship launch tower at pad 39A. That tower going up now 3 segments, as many as 9 segments we expect to see erected at pad 39A in the coming weeks. So with this rollout operation complete or nearing completion, we're going to sign off of our coverage of this event. The Atlas V is scheduled to launch tomorrow at 6 p.m. Eastern Daylight Time, or 2200 UTC. That's the opening of a 2-hour window to launch the USSF-12 mission for the United States Space Force. This mission will be carrying 2 satellites for the military to a geosynchronous orbit more than 22,000 miles, or nearly 36,000 kilometers over the equator. One of these missions is called the Wide Field of View Test Bed. It will be demonstrating a next generation infrared sensor that the military and DoD hope to use in their next generation missile detection, missile tracking, and missile warning systems to give US and allied forces advance notice of potential enemy missile launches. The other spacecraft is called USSF-12 Ring, and it's a propulsive ring-shaped spacecraft produced by Northrop Grumman that will be carrying a number of classified experiments and technology demonstrations for the military. And before I sign off, I'll remind you we'll be covering the launch of a SpaceX Falcon 9 rocket tonight or this afternoon. That launch is scheduled from pad 40, just down the road from pad 41 here at 5:04 p.m. Eastern Time, 21:04 UTC. That is the opening of a 2-hour window for that mission from pad 40. SpaceX will be hauling into orbit the SES-22 commercial communication satellite for SES, one of the largest traditional communication satellite operators. And this satellite will be providing C-band, TV broadcast, and radio broadcast services over the United States. We'll begin our coverage of that mission. We'll be covering that mission this afternoon again, beginning a little over an hour before that scheduled launch time at 5:04 p.m. So 2 launches on tap over the next 2 days, a Falcon 9 and an Atlas V. Today you see the Atlas V on pad 41. We hope you'll join us on our YouTube stream. If you want to become a member of our channel and help support our coverage, that would be greatly appreciated. You can also contribute through the superchat function and become a Spaceflight Now member on our homepage at spaceflightnow.com. So until this afternoon, a few hours from now, you'll hear from me again during the countdown of the Falcon 9 rocket. I'm Stephen Clark reporting live from Cape Canaveral Space Force Station.